Great. Hi, everyone. Thank you for joining today's event, How to Succeed with a Hybrid Cloud Data Warehouse, Deliver Breakthrough Real-Time Connected Analytics. We'll be featuring a live interactive conversation between Emma McGrattan, who is a Senior Vice President of Engineering at Actian, and our special guest today, Dave Menninger, who is a Senior Vice President and Research Director at Ventana Research. Dave has extensive industry experience in the analytics space. We're very excited to have him join us today as our special guest to share his insights. So just some housekeeping items before we get started. If you encounter any technical or audio issues, please let us know via the chat channel and we'll address them right away. And also this session is being recorded, so you can share it with your colleagues or rewatch at your leisure when we share the link with you tomorrow. And following the conversation between Emma and David, they'll be answering your questions. So please use the Q&A panel to ask any questions throughout the session, and we'll address them at the end. So with that, I'll hand over to Emma and David.
So Dave, thanks for joining us today. Really appreciate it.
Sure, happy to be here.
Tell everybody a little bit about yourself.
So I've been in and around the data and analytics market for most of my career. Spent 25 years on the vendor side, bringing different products to market in the data and analytics space. And now I study that market for Ventana Research.
And what are the areas in which you're focused?
So I look at really the entire stack of collecting and managing data, bringing it together and integrating it, transforming it, consuming it and analyzing it in any form or factor, including AI and machine learning.
Great, thanks, Dave. And one of the things that I'm really curious about is what's the impact COVID is going to have on the way we do business going forward, and more particularly, I guess, in relevance to the conversation that we're having today is what becomes the new norm? How are businesses going to adjust their BI and data warehousing initiatives as we move forward?
Well, I'd like to think I have a crystal ball and can see the future perfectly, but let me tell you what I think my hope is, rather than a prediction of what the future will be. My hope is that we take these types of things more seriously, meaning the processing of data and the use of data in our normal day-to-day business operations, right? This situation is really about agility. It's how well can an organization respond to a change in the market. Now, granted, this is a dramatic change in the market, but in a smaller context, it's really the same thing that organizations should have been dealing with in the past. So what I think the new normal is going to include is more organizations being equipped and being aware of the need to be able to use this information at their disposal to help them be more agile with their business processes.
I agree with you. Now, if I were being very selfish, I would ask the next question would be, what are people going to consider when looking specifically at data warehouses going forward? I think cost is one element that people are going to be focused on, but do you have other thoughts on that?
Well, warehouses are the way in which organizations deal with large amounts of data and take this information and try to use it to figure out how should they be responding to the current situation, right? So we have a collection of information. We need to manage that somehow. And so data warehouses are the vehicle by which we do that. And the specific considerations that I think are important right now are hybrid cloud capabilities, real-time processing, I think integrating the information into the data warehouse, and the performance, which is very closely related to cost, right? I mean, you could somewhat equate those two things, but those are the four key factors that I think organizations ought to be thinking about right now.
So Dave, I know you have a lot of really interesting research that you want to share with us, so perhaps we could turn over to that.
Sure. So let's start with hybrid cloud. And I say hybrid cloud because we really do need to think about the way in which organizations are operating today, the way in which they'll be operating in the future. Let me start with a little bit of the data that we have. People are moving to the cloud. There's no question about that. Our research suggests that the vast majority, 86% of organizations participating in our research on data and analytics in the cloud, indicated that they expect the majority of their data will eventually be in the cloud. Now, it's not all there today, and it's not even there for the majority of organizations, but it indicates the direction in which organizations are going, right? They're clearly going to the cloud for a variety of reasons. One is simplicity of managing the information. One is cost, right? There are a number of reasons to do that. But even when we look at it in the big data context, we see that a third of organizations already have their primary data lake platform in the cloud. Now, if you think about data lakes in the cloud, and I think we should think in this context of data warehouses and data lakes as being very similar, if not identical in many cases. Our research shows that many data lakes are implemented with relational technology. So the distinction between data lake and data warehouse isn't necessarily as dramatic as other people might think. It's more about being able to deal with volumes of information. And the reason many of these organizations are running their data lakes in the cloud or their big data warehouses in the cloud is because these can be complex things to manage, to set up, to install, to monitor. And by working through cloud-based implementations of those things, they can offload some of that work to the vendor that's providing those services. So, ease of use is clearly one of the reasons that organizations are working with the cloud. But, the other thing to think about is not everybody's in the cloud just yet, and not all of their data is in the cloud just yet. So yes, the trend is absolutely clear. Organizations are going to the cloud, but it's also clear that lots of data is still on premises, right? So when we ask organizations, where are you moving your data from and to? It was part of the research that we did. We asked organizations, are you going from on-premises to on-premises to cloud, vice versa, or cloud to cloud? And it may not come as a surprise to some, but to others, it may be a bit of a surprise that 2/3 of the respondents indicated that they're moving data from on-premises to on-premises. Now, not to the exclusion of doing the other things, but in 2/3 of organizations, they have the need to move data from on-premises to on-premises. Now, about 1/4 of organizations were moving data from the cloud to on-premises or from on-premises to the cloud. And, a smaller percentage, about 15%, are what you might consider to be cloud native companies or cloud native data movements where the data is moving from cloud to cloud instances. So what this suggests is that, yes, people are going to the cloud. They're not all there yet, and you clearly need to have a mechanism for dealing with this mixed world, and hence my emphasis on hybrid cloud capabilities. You really do have to be able to live in this world of hybrid cloud capabilities. So
So
that's a little bit of research.
Thanks. No, these statistics are fascinating to me, and particularly that 86%, because when you put that number up there, I assumed that most of that data was being generated in the cloud. But in fact, what you're saying is that some of that data is being moved from on-premise to cloud. And then the fact that we're always going to have data sets that will remain on premises, right? So when we do this on-premises to on-premises data movement, I'm assuming that's mostly data that's subject to regulatory compliance requirements. It might be medical information. It might be PII data. What types of data do you see as remaining on premises, and what are some of the bigger challenges that will continue to be deployed on premises because cloud's not quite ready for them, or the customer's not ready for cloud?
Sure. When we've looked at this in the past, one of the main reasons were security and compliance concerns, right? So highly regulated industries, I suspect, is a significant part of this. Healthcare, financial services, PII in various scenarios where organizations want to make sure they have that locked down well. But, I also think that there's a variety of reasons why information might be on premises. So for instance, I don't know if you looked at the Box IPO. When they were doing their IPO, they actually moved from cloud-based services to on-premises because they were consuming so much cloud-based resources that economically it made more sense for them to be doing some on-premises work. So there's a variety of reasons, but yes, I certainly think that regulatory reasons is a significant reason why some of this information will be on-premises. And the other one is just inertia, right? So organizations have stuff on-premises, and sure, they may be moving it over time to the cloud, but it may still be on premises.
Fascinating. Great.
So maybe you can tell us a little bit, Emma, about how you guys are dealing with the hybrid scenario, what you're seeing in your customers, and what you have in the way of offerings to span that world of hybrid capabilities.
Yeah, so we introduced Avalanche last year, and Actian Avalanche is our cloud data warehouse platform. And this year we've extended it to provide Avalanche Connect, which is essentially our data integration technologies that allow you to bring data into the cloud. And when we had this shiny new object, oh, it's a cloud data warehouse, and everybody's looking at cloud data warehouses, once we began the conversation with prospects and talked about the fact that we have a technology that started as an on-premise solution that we re-platformed for cloud, they get really interested in the on-prem part of this. So they have workloads that they've decided are ready for the cloud, but they're maybe not ready to move everything, forklifting everything over to a cloud environment. So what we've done with our Actian Avalanche technology is that we've said, well, we can continue to have that on-premise footprint, and there are new use cases for it, and we will, obviously attract a lot of interest in what we're doing on the cloud. But if we could provide a mechanism through which you could query both the on-prem and the cloud deployment as part of the same virtual warehouse, and that could be really interesting. So we're working right now on a hybrid federated query where you define which tables within your various warehouses are going to be part of the federated query, and then we're able to figure out in our federated query engine which are the which parts of the query are going to be executed where. So we do a query push down into the different data repositories, pull out the pieces of the answer from those data repositories, and then we aggregate those sets of results together and return the results to our end customer. So this will allow people to take the same technology that's running on premise as running in cloud. And later this year, we're implementing a VPC, which essentially will allow customers to take our cloud managed service but run it within their cloud infrastructure. So they may do that because they've got a better discount with the cloud vendors than we have, right? So it's in their interest to use the infrastructure discounted at whatever rate they can get from the cloud vendor. Or it may be from a security perspective, right? They want us to provide a managed service, but they want all of their data to be sitting on disks that are part of their cloud infrastructure. So we think that by giving the flexibility that you can run on-prem, cloud, private cloud, managed by us, managed by you, and we're able to meet the needs of all of the various use cases that some complex organizations require. And then this federated query has some intelligence built into it that allows you to query all of those different data assets as though they're part of a single data warehouse. So it looks like the same data warehouse, and you don't have to have the same data model. They can, in fact, have different models, and you don't have to be running on the same operating system or cloud platform. You run it wherever it makes sense for your business. So that could be Windows on-prem joined to a massive data lake, Hadoop infrastructure running in cloud, and it delivers this superlative performance across all of them.
That's great. I mean, the consistency across platforms, I think, is really important, and being able to tie them together is important. Often we see vendors describing hybrid as, oh, you can run it here or you can run it here. Not that they know anything about each other.
Right, right. So we have some grand plans here to build in a lot of intelligence, right? So when you build out a query execution plan, you have certain knowledge about how the data is laid out and how the network infrastructure is laid out, or at least you think you do, right? Until you actually run the query and then you discover there are some things that you weren't aware of. So the plan is that we would continue to build up intelligence on how the data and the network infrastructure is laid out, and just build better and better query execution plans. So it's a very exciting project for us right now, and it's picking up a lot of steam. So Dave, another thing that, performance is something that we're really focused on with Avalanche. So we designed Avalanche for on-premise deployment on commodity hardware, and we wanted to beat the competition, being the incumbent relational databases that have an on-prem footprint by 100x. That was the initial design goal. And in doing that, we built a solution that was designed for the limited resources that you'll typically encounter in an on-premise deployment, right? So you can't assume that you've got infinite compute and infinite storage. So we designed it so that we get the very most out of the CPU by using vector processing that allows us to execute operations on large volumes of data at the same time, and gets the most out of the CPU processor. We also have designed it so that we're using CPU RAM for execution memory, so that also allows us to deliver superlative performance on commodity hardware. And we have that very efficient use of DRAM as well, and our I/O algorithms are incredibly smart, so that we're storing data as columns. It lives its entire life as columns. It's a pure columnar implementation of the database. We've got some indexing that we build on top of the disks, so that we know what data is located where, and we're able to very easily pull from that. But you can go back to the previous slide. But all that to say is that we designed for a world where there was a scarcity of resources, and we found that when we get to cloud, that's actually stood us in really good stead, because cloud is nothing but commodity hardware built at scale. So we're able to deliver significantly faster performance than the competition in the cloud, right? So we see Snowflake getting a lot of attention. They've got great technology and some people I really admire over there. But when we look at what we can deliver for a single user in the cloud, we get about 8.5 times the performance that Snowflake gets. And I think a big part of that is that because we designed for efficiency, right? They designed for cloud. So they designed assuming an abundance of resources. There's limitless CPU and limitless disk. And I think that's one area in which we really excel. The other being as you scale the number of users, we designed for an on-premise deployment where typically you'll have a dedicated server powering your data warehouse, and you'll want to bring more users into that environment and have fairly high concurrent environments. So when we scaled this test that we ran from just 1 to 20 users, we found that performance advantage that we had over the competition grew. And the way I see it is, most companies that we're talking to about analytics want to give all of their business decision makers a copy of the tool of their choosing. It may be Power BI, maybe Looker or Tableau or whatever, and give them ad hoc query ability against the data set to allow them to kind of do the self-service analytics, which I think is really important. And the architecture that we have lends itself really well to bringing large numbers of users into the environment and delivering that superlative performance, whether you're on-premise running on a Windows laptop or you're on the cloud running on a 128 AU cluster.
Well, performance is really important, and maybe a couple use cases might help illustrate why it's important. So some of the scenarios we see are, for instance, related to predictive maintenance. So in a manufacturing scenario, you've got this big, expensive equipment, and you want to keep that equipment operating. You need to be taking real-time feeds from the various sensors on the machine and using that information to understand, is this equipment likely to fail? And the issue isn't so much preventing the failure. The issue is making the failure less painful, right? So a piece of equipment needs to be maintained, and if you can catch it before it causes some other catastrophic failure, you're going to suffer less downtime. And so often in these predictive maintenance scenarios, the issue is not just about the preventing a failure, but it's about the associated downtime that would go along with that failure. So we can detect a problem. You need the performance in the analytics and collecting the data and processing the data to be able to do this in real time, so you can be constantly doing it and shutting down the equipment in a graceful way, when necessary. Another example, so not everybody who's listening may be in a manufacturing environment, but another example that really sort of cuts across industry segments is the customer service center or websites, right? I mean, the whole notion of interacting with your customer base, often there are real-time elements to that. So if it's a call center, right, you want to be able to equip the call center representative with some information that helps them have a more valuable and a more meaningful interaction with the customer, maybe making recommendations. We see that one of the most common scenarios of applying some of these analytics of big data is improving the customer experience. So if they can take the information from past customer interactions and in real time perform those analyses, and recommend to that customer that they're interacting with, here's the way to resolve your problem, that is going to result in a better customer experience, likely more customer loyalty, and likely more revenue, follow-on revenue as a result of that, and or more new customers because of the reputation that you develop in the market. Same thing with websites, right? People are interacting with websites. You can be observing their pattern of movement through the website. You can be seeing what they're putting into their shopping cart or what shopping carts they're considering abandoning. And if you can react in real time, you can convert more of those interactions with customers to revenue. And again, you can provide a better customer experience. So, you know, it's really important to be able to have that performance and be able to deliver that type of performance in the solutions. You know, what types of scenarios are you seeing among your customers in terms of real-time necessities and these high-performance analytics?
Yeah, it's a great question because every customer we have where we mention real time, they have a different expectation of real time, right? So if we're in financial services and they're making trading decisions, real time to them is single-digit millisecond responses on analysis. For other customers, real time is 15 seconds, right? It's more like a human real time. It came back within my attention span, right? So, so there's a couple of things that we look at. So the first is real-time data ingestion, right? So being able to feed the data into the database at the speed at which it's happening within your business. So let's say you're using, you know, SAP, sitting on top of an Oracle database for your ERP system. As those transactions are happening, you want to feed those into your data warehouse so that, you know, if there's supply chain and so on being fed from the data warehouse, that's all happening in real time. And we're also seeing more use of streaming frameworks like Spark Streaming and Kafka. And this ability to take data in real time is something that was really important to us. And so, you know, we talked earlier about, you know, performance really matters for us, and the performance of that real-time ingestion was something that that we focused on. We actually have one of my engineers did his PhD thesis on real-time updates in a columnar database because it's a real challenge, and nobody had solved it in a performant way, and it's something that he did. So being able to, you know, satisfy queries in real time was also important to us. So this real-time insights into the data, being able to respond in millisecond timeframes to customers was important to us. And that's when it's a pure analytics use case, right, where the data is in the database and we can handle a query, get the response back within milliseconds. Really important to some customers. Other customers may want to take data into the database, do some data prep, load it into the database and query it and have all of that come back within a second. So different customers have very widely different expectations of real time. So what do you typically expect when customers talk to you about real time? Is it the same thing where they have a wide variance of expectations as to what that means?
Well, let me share with you some of our data. So we ask people about this, and this is particularly in the context of event data, right? Things that you would think might have some low latency requirements associated with it. But we see that about 13% of the participants in our research needed to process that data in that millisecond type of time frame that you were talking about. And you can imagine those scenarios. You mentioned trading, right? You can imagine in a manufacturing scenario where milliseconds might matter, you know, in a very expensive piece of equipment, keeping it operating properly and within tolerances. But a very large number of people also reported, another third of the participants reported that they needed responses in seconds. Now, for many organizations, that's pretty much real time, right? You know, if you're a customer service rep and you're doing something over the phone with a customer, and within a couple seconds you have new information on your screen to help guide your conversation with that customer, that's effectively real time as well. So, you know, I would group both of those categories into what I would consider as real time and what I think our research participants consider real time. But you know, it doesn't slow down a lot from there. People still, you know, a large portion are operating in minutes or in hours. You know, we've gone from the monthly, quarterly processes, weekly processes, even daily processes to these multiple times per day types of activities. And in about half of the cases, we're seeing that, you know, organizations, in my opinion, need to effectively operate in real time. Those seconds or milliseconds are about half of the scenarios where organizations are collecting some sort of event data. And I've labeled this slide, streaming data is the new black. I think that there are fundamentally two sources of big data. One source of big data is this event information, you know, from, say, IoT devices. And the other source of big data is unstructured information. So, you know, those two things are really what are driving the volume of information that we're seeing today. And when you're dealing with the streaming portion, there's some really important characteristics. You've got to automate more, right? You and I are not going to sit in front of a monitor and look at the data that's coming through and react to that data. I'm not saying that won't happen. There's some of that going on, but that shouldn't be your primary mechanism for dealing with streaming data. You've got to automate some of these analyses. And automating analyses even means automating the thresholds. Let's say you're an organization, let's just pick a number, 1,000 sensor devices in your organization. Are you going to manually set the thresholds for all those sensors? And people are under the misconception that, sensors are, are similar from one piece of equipment to another. Well, you probably acquired those sensors in different periods of time, and the manufacturer changed their specs over time. So the same sensor, quote unquote, isn't exactly the same in all these different implementations. And so the notion of just setting the thresholds for the sensors is an example of where we've got to apply more automation to the process. And our research suggests, unfortunately, that the majority of organizations are not even setting their thresholds automatically, never mind processing the data automatically. So our research suggests about 40% of organizations are setting the thresholds automatically and processing the data automatically. But just because you're operating with streaming data doesn't mean your historical data goes away, right? The way you develop those automated processes is that you take the historical information, and often that's very large amounts of information, right? Because you're looking at lots and lots of very minute levels of detail of information over long periods of time to develop the models that suggest what should we be doing in the future? How should we respond to a particular situation? So let's just take an example. Go back to that predictive maintenance example. Hopefully, your equipment is mostly running normally. So you're getting a response from the sensor. I'm here. Everything's normal. Temperatures, 82 degrees, 82 degrees, 82 degrees, 82 degrees. Then you get something that's out of normal, right? Okay, so you got one thing that's out of normal. That's not going to tell you a whole lot. So now you have to collect a whole bunch of examples of the out of normal situation. So this is why you need these very large amounts of historical data, because you have to have enough occurrences of the out of normal situation. And it's not always out of normal. It could just be customer segmentation, right? You need enough occurrences of customers in that segment to be able to develop some sort of model for automated responses to the situations that you're encountering. So streaming data is important, but it doesn't negate the importance of historical data. You still need these stores that can manage lots and lots of information. And once you've developed the models, you need a place to deploy them in line. So can you deploy them in the database? Can you deploy them in the Kafka streams? Can you deploy them into Spark streaming, right? Those are the things that you need to be able to do with the models once you've created them. And the last challenge with streaming is that, unfortunately, the models don't stay the same all over time, right? Your model developed yesterday is probably already getting stale today, because things have changed. Imagine the models you developed immediately before COVID, right? After COVID, those models are not very relevant probably. So you need ways to update those models, to inject new models into the processes, and to the extent you can combine these things with the databases, that makes it a whole lot easier to do these processes than to have to extract information out of a database and do something outside of the database with these processing. So streaming data is interesting, and it introduces some new requirements, but does not eliminate the requirement for dealing with large amounts of historical data.
So streaming data is definitely interesting and something that we hear a lot of from our customers. And we also hear a lot about semi-structured data and JSON and so on. What other data varieties do you see?
Mm-hmm. So, we look at the types of different information that organizations are working with, and we've got some of the information on the screen here. Not surprisingly, financial systems are one of the most common sources that organizations look at. Their data warehouses are a common source of information. Traditional transactional data is up there. But part of what we see when organizations are working with data is that not all their data is internal. And so, we talked about IoT event data as being an important source of big data. Machine data, or the logs of information, they're not really unstructured, but they're not really structured, right? They're kind of in between. A row in a log might not have the same format as a previous row, right? So an error condition in a log file probably has a different format than a success condition in a log file. So you can't just load that information into a table without any kind of processing of that information. So some people lump that into the unstructured or semi-structured category. They're certainly using lots of different sources of information. 3/4 of the organizations are using more than 5 different sources of information. But where we start to see unstructured information really hit home is when we start looking at external sources of information that organizations are working with. So, any organization that's dealing with customers, large numbers of customers, is going to want to understand what information is available in their social media profiles and publicly about that customer, right? You can get a much more complete picture of a customer if you're looking at the information that's available publicly, what they tweet about, what products and brands that they're working with. Are they having good experiences or bad experiences? So social media tends to be the most common type of unstructured information, external data source that organizations are working with. And so, they need to take this information. It doesn't necessarily fit neatly into rows and columns. So you have to have a mechanism to be able to store it. And then you have to have a mechanism to be able to process it. So to say that it's unstructured is a little bit of a misnomer. It's structured. It's just not structured the way we'd like it to be structured. So usually what happens with unstructured data is that one of the first things you do is process it to create some structure. How many times did the customer say something positive? How many times did the customer say something negative? Well, that's even a couple of steps down the line. To get to that, you probably are parsing the text in the social media to see how many times did this word or phrase occur in the text. So ironically, you're actually taking the unstructured or semi-structured information and creating a lot of structure out of it. But if you don't have that mechanism to deal with the source data, how are you going to do that processing, right? So it all starts with being able to capture and manage this unstructured information. And if you get to the slightly more structured information, the machine learning, the IoT event data, people are using that and creating the appropriate structures around it to do machine learning types of activities and learn from that information over time. And then, we talked about, I mentioned sentiment analysis, although not by name, but were people having good experiences or bad experiences. But we even see things as sophisticated as store traffic analyses. So if you take video information of foot traffic through a store, there are techniques to analyze the movement of people through the store. You can actually get more or less the same type of analysis that you get about people's movement through your website. Right? You see where they spend the most time. Are they spending the most time? That's why those end caps, the end of the aisles in retail locations are considered to be so valuable, is because you know that you get more face time with customers at the end caps. And these video analyses of people moving through the stores really help identify where the most valuable locations are within the store. And then that allows the organization to price that space differently, to put different products there, that they want to promote more heavily. But those are a couple of different examples of the types of unstructured information that organizations are working with, and some of the things that they're trying to do with it. So I know you mentioned earlier we were discussing JSON capabilities, and so maybe you can tell us a little bit about how you're dealing with unstructured data in the Avalanche world.
Yeah, sure. So we've added support for JSON very recently. Actually, it's our very latest new feature added to the to the analytics service, and the reason we added it was we saw a lot of demand for it in like financial services where they're using it as a data exchange language. So being able to parse the JSON, to load it into the database in a way that's very simple for you to see what's within those JSON files, to load that at speed and to be able to query it at speed was something that was important to us. And to me, it's just another challenge on data integration, right? So all these different types of data require different data integration technologies to bring that data into the warehouse. So I was curious about your thought on data integration. As you'll see when I get to our demo in a few minutes, we view the data integration capabilities that we provide as just as important as the analytics capabilities that we provide, and we're building out a platform that has data integration built into it. But what are your thoughts on getting this wide variety of data into the data warehouse?
Well, it may not come as a big surprise. I think different analysts, including ourselves, have talked about this fact that the most time-consuming part of the analytics process is actually accessing and preparing the data. Right? That is a big challenge. If all your data were perfectly available and perfectly organized, it'd be easy to do some of these analyses, or easier, let's say. We see it not only in traditional analytics, but when we look at AI and machine learning, continues to be a big challenge. Trying to bring in external sources of information is another challenge. We look at this as a critical part of the process, based upon what we see in the research that we conduct. And so being able to integrate those capabilities with the other capabilities in your data and analytics processes is a way to make that process easier and more streamlined, right? If I don't have to learn two different environments, if I don't have to go from one environment to another environment, it's going to make those processes have less friction and allow me to move through those processes more quickly. That's important. But you'll also notice on this chart here, the last item that people have a challenge with is deploying the task into production, right? So okay, great, I've done some manipulations of data, but then how do I make that a repeatable process in my organization? And so again, integration is a way to tackle that issue. So we see that as an important capability. As we go further, we look at the next slide. We've got reusability as being really important. So having these things as objects or jobs or processes that can be reused, can be easily accessed and shared within the organization is what people consider the most critical capability in being able to prepare their data for analyses. We highlight here the notion of joining information together, go back and touch on the real time again. These are all things that people consider to be critical in their ability to work with the data, and deploying them as services. Again, that notion of putting these tasks into production. So, to the extent you can integrate these things into one platform, that's going to tackle a lot of these issues that organizations are facing. So maybe you could tell us a little bit about some of the things you've done in the connected data warehouse to make these types of things part of your platform.
Yeah, sure. So I think it's probably best illustrated through a customer example, or this great chart here, and then we'll get to a customer example. I mentioned that last March we introduced Actian Avalanche hybrid cloud data warehouse to the market. Started with an on-premise footprint, we then moved it to cloud. And in doing that, we needed to do some work like being able to separate storage and compute so that you could scale those two independently. We needed to look at performance. We built a managed service around it, taking the years of experience that we've built up managing customer deployments, and that is a very complete cloud data warehouse solution that performs really well. So then what we said is, in the Actian portfolio, we had a whole broad set of data integration technologies. And what we wanted to be able to do is to provide those data integration technologies as kind of a natural extension of the data warehouse. The thinking being that first thing you want to do when you create your brand spanking new data warehouse is start loading in some data. So the data integration technologies that we have cover bringing data in from the likes of data lakes, right? So I think in the past we've seen a lot of Cloudera and Hadoop being used for data lakes, and we'll see Parquet files sitting on HDFS that need to be brought into the warehouse. But more recently, we're seeing a lot of cloud storage being used as a data lake. So just kind of a data dumping ground where we can go out, reach into it, find little nuggets of information, make sense of those, do some data prep, data enrichment, and then bring that into the warehouse. We've also seen that people have had a lot of success with SaaS applications like Salesforce and NetSuite and ServiceNow, and being able to provide the ability to build out templates for common integration paths and make those part of the platform. So that's what we're focused on right now, is building out those templates. So and maybe if you're a Salesforce user, you want to take the contacts table from Salesforce, bring that into your warehouse for creating a customer 360 view in the warehouse. So being able to identify that object, pull the contents into the warehouse, and providing a template through which you just specify your credentials, your access credentials for getting to your Salesforce instance, and then you can bring that into the warehouse. So getting to SaaS applications was important, but we also come back to the earlier point about the fact that on-premise applications and on-premise data is probably here for at least a while. And we also provide support for commonly encountered on-premise apps like SAP or Oracle with like PeopleSoft or Siebel with Microsoft Dynamics, and again providing the ability to take data assets from those apps and bring it into the warehouse. And we want to make it extensible, so pretty much anything that supports a REST API we can reach out to. We can schedule these jobs to run at a given time, or we can schedule them to run if an incident were to happen. So getting back to your earlier point about a lot of the work that you're doing, identifying what's happening in production lines, right, and instrumenting that entire production line. And if this event happens, I want this to trigger. Our Kafka streaming framework is something that we can demonstrate right now, but we're it's not yet productionized, so it's kind of down here in a paler gray, and that's coming quite soon. So these are the integration technologies that we provide, and I'm going to talk about a customer use case in a minute or two. But we also recognize the need for partners in this area, right? So when we go out and we talk to let's say it's a telco company that's contemplating moving from a solution like Netezza, and they want to come to Avalanche, they've probably made a significant investment in IBM data stage jobs, right? And they probably have thousands of these jobs, and all they want to be able to do is to change the endpoint of those jobs to be Avalanche as opposed to Netezza, and that should be the only change that they have to make. So being able to provide support for data stage and for Informatica, we come across that a lot with Teradata customers, and so being able to work with third-party ETL and ELT technologies was important to us. And then at the bottom of the screen here, getting back to our earlier conversation about RealTime, and working with partners like HVR is our chosen replication partner, and they have broad platform support and they're focused on performance. So using HVR for change data capture, right, and being able to take those business transactions as they're happening within the business and loading those into the warehouse so you get real-time insights was important to us. Another important partner ecosystem for us was on the business analysts tool choices, right? So working with the ones we encounter most frequently, including Power BI, Tableau, MicroStrategy, Qlik, and Looker, building out connectors for them so that they have native knowledge of the syntax we support, and that we have the ability to work with them quickly and fully functional was important to us. And then on the data science and data engineering side of things, we see a lot of open source technologies here, the likes of KNIME and a lot of Jupyter notebooks and Python, Spark SQL, and so on being used. So being able to meet the needs of the data science and the data engineering community was important to us too. So again, building that out through partner support. So this is a kind of a schematic of what the real-time connected data warehouse looks like, and we view it from two aspects, right? So it's real-time data ingestion. It's getting the data in here as you're transacting business, but also that ability to provide for real-time insights, right? So am I making a trade or not? The market's moving on, and making that happen. But I think it's probably best illustrated with a customer example. So I'm not sure how much time you've spent in the UK and Ireland, but the AA over there is the Automobile Association, and you could think of it as being very much like the AAA here. So started live, well, actually,
just more efficient, right?
Yes.
letters
Right?
instead of three.
But one of the things that they provide many services, including roadside assistance and travel guides and maps and so on. But one area that they've gotten into is the insurance industry. And what they set up, the goal was to be able to provide a request for a quote within 2 seconds, right? So when you fill in one of their online forms requesting an insurance quote, particularly, so the AA provides this on their own website, but they also work with these insurance aggregators where you can go to a single site and get 10 quotes. And the way those sites work is whoever gets back the quickest gets top billing on the site. So they're typically the ones that the customer's eye is drawn to, much like your end cap example. So the first thing they do is they accept that form and they need to do some data prep on it, right? So it might be that the date of birth has been filled out in some bizarre way, and they need to clean that up. And they'll also take in data from other sources. So once they've identified me, right, they can say, oh wow, that car she's driving, it might be a 2018. I'm not sure how she's driving it because we've had to provide her with roadside assistance 6 times in the past year. Maybe this isn't a great insurable risk for us. Maybe she's got some speeding tickets that we're now aware of or whatever. So they look at these outside sources of information as well as some of their own sources of information, pull all of that into the picture for generating this insurance quote. They need 2 things in that quote, speed and accuracy, right? So once they issue a quote for me as a driver on my given car, they need to stand by that quote, and they need to make sure that the insurable risk is represented within it. So to me, while this is, their aim is for a sub-second response time, started with a 2-second response time, because that's the kind of patience people have as they interact with their website. I view that as a real-time use case, right? So it's not the single-digit millisecond use case that we deliver for the likes of Thomson Reuters and their trading platforms, but it is in a sense, a human real-time use case where seconds and sub-seconds are important. So the platform enables them to take that form, do the data prep, cleaning up some of the data that was provided, doing data enrichment, pulling in credit scores, driving records, the car's history, and so on, and then generating a realistic price. It then stores all of that information in the data warehouse, so they can do win-loss analysis and so on. So this is one of the sites. When I talked earlier about that, a lot of our customers want to be able to provide all of their business decision makers with access to all of the data and using ad hoc querying for it. This is one example. So maybe the best way of explaining the platform is to give you a quick tour of it, Dave. What do you think?
Sure, that sounds like a good idea. I was hoping you'd give us a demo.
Okay, so fingers crossed for me here, right? So let's see how it goes. Okay, so this is the interface for the Avalanche Connected Cloud Data Warehouse. So when we come in here, obviously in the interest of time, I logged in advance, and when I come in and I want to create a warehouse, typically it's the first thing I'll do. So I'll give it a name like Ventana. I can choose now if I want to deploy this on Azure or AWS. Let's choose AWS just for kicks. I can then choose a region, and you can tell from the accent, Dave, that I'm Irish, so I'll go for an Irish data center. And now I can choose the number of Avalanche units. So an Avalanche unit is really a measure of the horsepower. Our 2 AU and 4 AU instances are dev test instances, and then 8 AUs and above are for production deployments. So I'm just going to choose a small 2 AU instance here. The warehouse is set up as a single tenant infrastructure, so there's no chance of data leakage in my warehouse. And for an added level of security, I can actually provide it with a set of whitelist IP addresses. So these are the only IP addresses from which you can access my warehouse. So here I'm going to say, you figure it out. I don't know what it is actually. So it figured out my IP address for me, and it's going to add that to the whitelist. If I were to decide that I want my engineering organization to have access to this warehouse, I can give it a CIDR block, and that's easily done. And then the last thing on here is this idle stop. So one thing that we had noticed was that the bigger the test environment the engineering team were setting up, the more likely they were to forget to shut it down at the end of the day. And it gets expensive when somebody forgets on a Friday to shut down a service that's going to keep chugging along till Monday.
I've had some unexpected cloud bills in my past.
They're never pleasant, are they? Those are rude awakenings. So anyway, we built into the service this ability to identify that there hasn't been a new query issued within an hour, and the last query completed. So likely someone's forgotten that they need to shut this down. So it will automatically stop the warehouse when it's not being used. So looking again at the cost side of the cloud. The one I created earlier, I made an 8AU environment, and the reason that I did that was because I wanted to show you that we can scale here. So in our implementation with Avalanche running on Microsoft Azure, we've separated storage from compute, and the reason we did that was we see a lot of people who have peak demands at the end of month, end of quarter, end of year for processing. Our customers in the retail space will have, Black Friday and Cyber Monday, where they just want to amp up the compute resources being allocated in the cluster. And they don't want to pay for additional storage, and they certainly don't want to redistribute the data in the warehouse, onto additional storage. And so this ability to dynamically scale the environment and bring, up and down the number of Avalanche units, just essentially the horsepower of the environment, was important. So that's all part of the platform. So now the other thing that's kind of cool here is that we have a query editor built into each of the warehouses. And when I come into the query editor, what you'll notice on the left-hand side here is it knows I've got a couple of schemas that I'm using here. And we actually took, I'm not sure if you're familiar with it, but the Department of Transportation has an on-time database where they release the flight information. So
yeah, I've seen that before.
On, right? So we've loaded up a year's worth of that data, and we provided some sample queries, because one thing we found is that people lack imagination when they start up a brand new warehouse and they want to start playing with it. It's like, oh, what data am I going to load? What queries am I going to run? So first thing we'll do here is we'll run a query that'll give us a count of all the rows in here. So it's 7.2 million rows, and it came back in 0.1 of a second. Right, so fairly fast. This data set's not particularly, I'm sorry, this result set's not particularly interesting, but for a broader result set, I could download the results, as I said, as a CSV file, as an Excel spreadsheet, as a JSON file. I can create a table from it. There's a world of things I can do here. But if I go for some of the more interesting queries, right, so I'm a person who travels a lot for business, so I'm interested in what are the top 50 flights with the biggest average delay, right? So when this query comes up here, it's kind of unreadable, right? So what I can do is I say, format that, right? So use a bit of smart formatting in here. So it presents it in a much more readable form. I now run the query. And as well as getting my results here as a table that now is much more interesting for me to export this as an Excel file. I also can have some visualizations on that, right? So in this case, I've chosen to represent this as a bar graph, and I can see for Delta's my airline of choice here, so I can see that I never want to go from Oakland to LAX, right? It seems like it's the most delayed route, and then Columbus, Ohio to LaGuardia, New York is it. So some interesting information that you can glean from it, and you can throw any tool that you want at this data warehouse. One of the things that we've done to make it really simple to use is we've identified which are the tools that we come across most frequently. So like Tableau, Squirrel for SQL jockeys, it might be Power BI, and you just say, okay, I'm going to be using Power BI with this, and then it says, okay, here's the connection string that if we click here, it will copy that to my clipboard, and now when I go into Power BI, I just need to paste that in, and I can start using Power BI. So I mentioned our integration technologies are now part of the Avalanche platform. Try that again. Okay, so if I come into integrations, I'll see that I have a couple of configurations that I'd already created. So one of these is to take a CSV file from ABFS, which is the Azure blob file system. I can take a look at this integration. There are a bunch of macro fields that you fill in. So basically you'll say, here are a list of the files that I have that I want to load into the environment. Here's the connect string for getting to my database. I probably shouldn't have exposed my super secret password there, so I can mask that. So in the future, right, nobody gets to see that. And then I say, which is the table that I want to load it into. And then I can go back out to my configuration, oops, and then run that job, right? So when I run the configuration, it will bring me into a list of all the jobs that have run. It'll show me, if I give it a second here to refresh, now it's running that new job. it's going to show me the steps of the running of that process. So here it's screen real estate issue here. But essentially what it's doing is it's parsing this file. It's identifying the different, it's using a header to identify the column names that it should be using. It identifies the data type by looking into the actual data within the file. Because we want to make sure that we're using the appropriate data type for things like dates versus characters versus numeric types. And even for numeric type, is it an integer, is it a float, are null values allowed, and so on. And then it will, when I go back into the warehouse now, I will have a table in my schema here. As I mentioned earlier, this was a very simple integration that I built myself for taking a delimited file from ABFS into Avalanche running on Azure. But this could be, using one of our templates to take the contacts table from Salesforce and move that over. I can set a frequency at which I want the jobs to run. I can set an event for them to run, and so on. But bringing all of this together, I think, is really cool. And it's one thing that I've learned over the past 12 months is that providing fast analytics is interesting, but providing fast analytics on up to the second data is far more interesting to our customers. So building these integrations in and making this as easy to use as possible has been important for us. That's
great. It's good to get to see the product.
Yeah, thanks.
Maybe just a quick wrap up. Hopefully we'll have time for a question or two, but I think it's really important organizations recognize that they have value in their data, and you need to figure out a way to use that data to create a competitive advantage. Especially in times like this. And, the cloud is important. Everybody's heading there, but make sure that you don't abandon your on-premises capabilities. You need these two things together. Most organizations will need both together for the foreseeable future. You just highlighted all the reasons that real-time are important. So I think that's an important thing to keep on your list as you evaluate different offerings. All the variety of data sources and data types that you're going to deal with, ranging from cloud-based business applications to unstructured or semi-structured data, and do whatever you can to reduce the friction in using these capabilities. And to the extent you can get more of them integrated into one offering, that's clearly going to help you be more efficient and more effective in your work. So Dahe, do we have any questions we can try and tackle quickly?
Yeah, thank you, Emma and Dave. That was great. So just a reminder to please use the Q&A panel to ask your questions. Looks like we already have a few in the queue. This question may be for Emma. So you talked a lot about Actian's fast performance. This gentleman wants to know what kind of DBA work is required to achieve that.
Oh, I love that question because none. So it depends upon the way you choose to deploy our technology. So if you choose the managed service, whether that's on public cloud or within your infrastructure using our VPC deployment mechanism, we can provide the managed services around that, so that you don't have to have DBA expertise. And we actually developed the technology to be set and forget type, simple to use. So it does things like it automatically indexes all the data as it's been loaded and so on, just to make it super simple. And so where we want to get to with this is that you start up the data warehouse, you load the data into it using the tool of your choosing or using one of our integration capabilities, and then you're ready to query it right away. And that's why within that interface, we've made it super simple to be able to, without leaving the console at all, to come into the warehouse, create or manage it, and to populate it with data and to start querying it right away, or to connect to your favorite tools.
Great, thank you. And looks like maybe one more question in the interest of time. Emma, you had shared earlier the calculation between Avalanche and Snowflake price performance difference. Can you share a little bit more about that study and how that was calculated?
Yeah, sure. So we employed a third party to take an industry standard, the TPCH, so the TPC is the Transaction Processing Performance Council, and they have benchmarks that are representative of typical business workloads. TPCH is a decision support workload. It's meant to be non-industry specific, so a very broad workload, and that you can deploy against a data warehouse. It was run at 10 terabytes against Avalanche and against Snowflake, as I mentioned earlier, with a single user and with 20 user. And we engaged a third party to run it to make sure that we weren't cheating at all. But since both of these technologies are managed services, there's not a whole lot you can do to game the system.
Well, it looks like we're at the hour mark and we want to respect people's time. So those questions we didn't get to, we'll get back to you over email. Thanks again, everyone, for joining, and thank you especially to Emma and Dave for your insights today. Have a great day, everyone.